Hello viewers, continuing our discussion on integrals, today we are going to take up an important method of integration, and the method is known as integration by parts. So viewers, let us start our topic. Uh, let u and v be any two differentiable functions. Clear? So viewers, in our previous discussions we have seen that if u and v be any two differentiable functions of a variable x, then the product rule for finding the derivative of their product is given by d by dx of u multiplied v is given by u multiplied by dv over dx plus v du over dx. Clear? This we have studied in our previous discussions. So this is known as the product rule for differentiation. Clear? Now here we are interested in finding out the integral of the product of two functions u and v. So we want to find the integral, the indefinite integral of the product of these two functions of x, u and v. Clear? So let us see how we can do this, or in other words we can say that let us derive the formula for integrating the product of two functions. Clear? So here we have equation 1, and let us integrate both sides. So integrating both sides with respect to x. With respect to x, we have d by dx, integral of d by dx of uv, and here we have u, this is dv by dx, here we have dx, and then we have v, this is du by dx, and here we have dx. Clear? So we are integrating both sides with respect to x. Now this can be written as, this equation can be written as d of uv of dx, sorry, here we will have only d of uv, and here we have u dv plus v du. Clear? Now this can be written as uv equal to u dv plus v du. Clear? So let us say this equation is equation number 2. Clear? Now viewers, we have this equation 2. Now also from this equation we can write the expression, the integral of d by dx of uv dx is uv, and we have u and dv over dx, this is dx plus v du over dx and dx. Clear? So let us say this equation is 3. Here what we have done, we have written this equation in this form. Clear? So we have uv, integral of u dv by dx plus integral of v dv by dx. Clear? Now this equation number 3 can also be written as, we can write it as, if we take this term to this side, we have u dv by dx. Dx is equal to, we are taking this term to this side. Clear? So yes, we have uv minus integral of v du over dx, and here we have dx. Clear? So this is equation number 4. Now viewers, here we will assume that, say this function u, let u is say some function f of x. Clear? And dv by dx, that is the derivative of v with respect to x, dv by dx is equal to, say, some other function g of x. Clear? Now let us substitute these values in equation 4. Clear? So therefore this equation 4 implies, here we have integral, this is u, and for u we can write f of x, and dv by dx is equal to the function g of x and dx. Clear? Equal to, now here we get the product of two functions f and g. Clear? Now equal to, here we have u times v. Clear? Now what is u? U is f of x, and what is v? From this equation, v is the integral of g of x. Clear? See, if we integrate both sides, if we integrate, we can write it, if we integrate both sides, we get v is equal to integral of g of x dx. Clear? Minus, and then we have the integral, and what is v? V is, here we will have a bracket, then the value of v is integral of g of x dx, and now here we have integral, this is the integral, and then we have v. V is integral of this is integral of g of x, and then we have du by dx, and this du by dx can be written as f prime of x. Clear? And here we have dx. Clear? So we have from equation 4 we have obtained this expression. Clear? Now this expression can be written as integral of the product of two functions f and g is equal to f of x integral of g of x. Here we will have dx also. Clear? So we have integral of gx, and then we have integral, and we have the derivative of f, and then the integral of g of x dx. Clear? And here we have dx. Clear? So this is the formula for finding out the integral of the product of these two functions f and g, and this formula is known as integration by parts. Clear? Now this function can also be written in this form. Suppose we have say two functions f and g, then we can write it like this: f and g dx equal to, this is first function, say this is second function. Clear? This is first function and this is the second function. Clear? So we can write the integral of the product of these two functions as f of x, that is the first function, integral of second, minus we have the integral here, then we have the derivative of this first function, which can be written as df over dx, and then we have the integral of second function, and then we have dx. So this is the final formula for integrating the product of two functions. Clear? Now viewers, whenever we apply this formula for integrating the product of two functions, it is very important to select which function is to be treated as first function and which is to be treated as second function. Clear? Suppose we have to integrate a function like this, x sine x dx. Clear? So here we have this is a polynomial function and this is a trigonometrical function. Clear? So here we have the product of two functions, f is x and g is sine x. Clear? Now this is a polynomial function. This is a polynomial function and this is a trigonometrical function. So whenever we have the product of two functions and one of them is a polynomial function, then we take the polynomial function as the first function. Clear? So we must take, or we must treat the polynomial function as the first function. Clear? Similarly, if we have to integrate a function like say x square log x. Now this is a polynomial function and this is logarithmic function. So here also we have to treat this function, the polynomial function. So in this case we have x square as polynomial function and log x as logarithmic function. So in this case the log function should be treated as first function. So we must treat a logarithmic function as the first function. Clear? So when we have a polynomial function with trigonometrical function, then we must treat the polynomial function as the first function and the trigonometrical function as the second function. Clear? Here we take it as first function and we take it as second function. But when we have a polynomial function with logarithmic function, or if we have x square with inverse trigonometrical function, then in these two cases we must consider this as the first function. Clear? So and this is to be treated as the second function. So what we have concluded here, so we have concluded that if we have a polynomial function with trigonometrical function, then the polynomial function should be treated as first and the trigonometrical function should be treated as second. But if we have a polynomial function with the inverse trigonometrical function or logarithmic function, then the inverse trigonometric function or the log function should be treated as first function. Clear? Now viewers, again if we have a product of two functions like say x square e raised to x. Now here this is polynomial function and this is exponential function. Now here also the polynomial function should be treated as the first function. Okay, so this should be treated as first function and this is to be treated as second function. Clear? Therefore we can conclude that if we have a product of two functions which is to be integrated, and if the nature of the two functions is a polynomial function or exponential function or inverse trigonometrical function and inverse trigonometrical function or trigonometrical function, then just for the sake of memorizing, we can remember that which function is to be treated by this word I late. Clear? So here I stands for inverse trigonometrical function. This is inverse trigonometrical function, and L stands for the logarithmic function, A stands for the polynomial function or the algebraic function, and T stands for the trigonometrical function, and E stands for exponential function. Clear? So here inverse trigonometrical function implies we have the function like sine inverse x. Here we have the logarithmic function, say log of x. Here we have algebraic function, say x square or x cube or x. Clear? Or a combination of say x square plus 2. Okay? Clear? X square plus 2. And here we have the trigonometrical form function, say cos x or tan x. Clear? And here we have exponential function, say e raised to x, e raised to 2x, and so on. Clear? So suppose if we have x square e raised to x, then by this rule we can decide which function is to be treated as first and which is to be treated as second. So here see this is x square is an algebraic function and e raised to x is exponential. So here a comes first and e comes after a, so therefore this a is to be treated as first function and e raised to x is exponential function, so this is to be treated as second function. Clear? Similarly, if we have a function like say x square log x, then we see that this is algebraic function and this is logarithmic function. So L stands for logarithmic function and L comes before A. Clear? So this is to be treated as first function and this is to be treated as second function. Clear? So this is just a method and to memorize which function, or this is just a trick, you can say a trick which is used to decide which function is to be treated as first function or second function. Clear? So viewers, let us solve some problems based on integration by parts. Now suppose we have to integrate x e raised to x. Now let us call this integral as I. Now here we see that this is a polynomial function and this is an exponential function. So by the rule I late, we see that this is algebraic function and this is exponential, so this function x is to be treated as first function. Clear? So we have the formula f, the product of f and g. The integral is given by f integral of g, then we have the integral of d by dx of f, and here we have integral of g and dx, and here we have dx. Clear? So here we have f is the first function, so this is x, and g is the second function, which is e raised to x. So we have x e raised to x dx is equal to f is x. We'll simply substitute the values of f and g here. So we have x, this is e raised to x dx, integral the derivative of x, and we have e raised to x dx, and here we have dx. So this is x, integral of e raised to x is e raised to x minus the derivative of x is 1, e raised to x is e raised to x, and here we have dx. Then we have x e raised to x minus integral of e raised to x dx, and here we will also have the constant of integration. So we can write x e raised to x, the integral of e raised to x is e raised to x plus c, and finally we write x minus 1 e raised to x plus c. So this is the integral of the product of these two functions x and e raised to x. Viewers, let us take this problem. We have to find the integral of x log x. Here log x is this is the logarithmic function, so let us take it the first function f, and x is the polynomial function, so take this function as second function. And here we have the formula for the integral of the product of two functions f and g as f, we have this g dx minus then integral of the product of the derivative of f and the integral of g. Clear? Now let us apply this rule to this integral. So here we have f is log x, so we have log x, then we have integral of x, and minus here we have the integral, then we have the derivative of log x, integral of x. Clear? Now here we have log x multiplied the integral of x, which is x square by 2 minus, and then we have the derivative of log x as 1 over x. Here we have x square by 2, the integral of x, and then we have dx. So this can be written as x square by 2 log x minus, here we have half, and then we have x dx. Clear? And now we can also add the constant of integration as c. Clear? Now this can be written as x square by 2 log x minus half times the integral of x is x square by 2 plus c, and this can be written as x square by 2 log x minus half plus c. Clear? So here's the integral of x log x is x square by 2 bracket log x minus half plus c. So here we have this polynomial function. This is polynomial function, this is logarithmic function, and when we have a combination of polynomial and logarithmic function, then the logarithmic function should be treated as the first function and the polynomial function as the first function. Now let us solve the integral of log x. Here we see that we have only one function. So when we are given only one function, as in this case we have the function log of x, then the second function is to be taken as 1. Clear? So we write this integral as 1 multiplied log x. Clear? So here we have only one function. So whenever we have one function, we take 1 as the second function. Now this is 1 and this is log x. So this log x should be taken as the first function and 1 as the second. This is as the first function, this is as 1 as the second function. So if we apply this formula to this integral, then we have log x multiplied 1 dx integral of 1 minus this is the integral of the derivative of here log x, and here we have integral of 1. Clear? And here we have dx. So this is log x times the integral of 1 dx is x minus the derivative of log x is 1 over x, then integral of 1 is x, and then we have this dx here, and the constant of integration as c. So this can be written as x log x minus x and x get cancelled. Again we get 1 dx integral of, and here we have plus c. This can be written as x log x minus the integral of 1 is x plus c. So this can be written as x log x minus 1 plus c. So this is the integral of log x. Clear? Now suppose we have to integrate tan inverse of x. So here also we have only one function, though therefore the second function should be taken as 1. So we can write it as 1 multiplied tan inverse of x. Clear? Now here's this should be taken as the first function and 1 should be taken as second function. So by utilizing this formula, the integral of tan inverse x can be written as here we have tan inverse x as f, and then integral of 1 minus integral, and here we have the derivative of tan inverse x, then we have the integral of 1. Clear? Now the integral of 1 is x, so this can be written as x tan inverse x minus this is integral of the derivative of tan inverse x is 1 over 1 plus x square, and here we have x and dx. Clear? Now here we should also write the constant of integration as c. Now here's this is x tan inverse x minus, now c, here if we write this integral as this is x over 1 plus x square dx plus c, and if I multiply the numerator by 2 and the denominator by 2, then it doesn't make any difference. So because 2 and 2 get cancelled. But here we have one interesting thing, that is the 2x is the derivative of 1 plus x square. So the integral of this function is log of 1 plus x square plus c, because we know that if we have an integral of this form, fx is in the denominator and the derivative is in the numerator, then the integral of this function is log of f of x. Clear? So the integral of 2x divided by 1 plus x square is log 1 plus x square. Clear? So this is the integral of tan inverse x. Clear? Now suppose we have to integrate x sec square x. So here's, this is trigonometric function and this is a polynomial function. So this should be x should be taken as the first function and secant square x should be taken as the second function. So therefore, applying this formula to this integral, we have x integral of sec square x minus integral the derivative of x, then we have the integral of sec square x, and here we have dx. Now the integral of sec square x is tan x, so we have x tan x minus the derivative of x is 1, and the integral of sec square x is tan x, and this is dx, and the constant of integration as c. So we are, viewers, we have x tan x minus integral of tan x plus c. Now we know the standard result for the integral of tan x, because integral of tan x can be written as sin x over cos x, and the direct formula for integral of tan x is minus log of cos x. So we substitute it here. So we have minus of log of cos x plus c. So this is x tan x minus minus plus, and we have log of cos x plus c. So this is the integral of x sec square x. Clear?